those regulations. Now, when I talk about data center failures, I've lived in Asia for over 20 years now, and people will say, well, of course, in Asia you have unreliable data centers. But this is a table from an article from one of our sister companies, which is talking about some of the data center failures around the world in the last 3 months. So this is just 3 months. And if you look at the names there, Delta Airlines, Southwest Airlines, Global Switch. Now, you may not be familiar with these names. Delta and Southwest are two major US airlines. When their computer systems failed, they cancelled 1,800 flights and lost 10% off their quarterly earnings. Southwest lost 2,300 flights, and the CEO was left having to probably explain why he had underspent on his IT systems. And Global Switch, who are a $5 billion UK-based data center company, whose only product is data center reliability, failed twice. And this is what's happening in the world in the last 3 months. And the reason why this is becoming such an issue is that so many businesses are now putting so many of their systems onto data centers, and we're all becoming totally reliant on them. And the effect is, data center reliability is really affecting businesses, and that's why people are getting very, very interested in it. And the causes of failure. Data centers can fail for many reasons. However, the research is clear. Of the 4 reasons, the most likely reasons, 3 of them are power, cooling, and people. You could look at this and say, as the article did, oh look, DDoS attacks on data centers are rising. They are. But what's also true is that data centers are still failing because of power, cooling, or people, exactly as they did 3 years ago, exactly as they did 20 years ago. So if you have a data center, you have to look at power, cooling, and people, because that's the reason it's going to fail. And we know this well, because as part of Uptime Institute, we actually have a network group of data center operators who talk about this and provide information. And again, there's articles on our website about data center reliability, but I can summarize it very clearly. This table shows you what we see from our operators all around the world about what's happening in data centers. Power, cooling, people. But also weather, because whether global warming is true or not, the number of data center failures which are now related to weather, for instance, just recently in South Australia, where the power failed to an entire state, they turned off the power stations, 2.5 million people with no power. That affects data centers. And although people talk about the East and say, well, of course, things aren't reliable out there. Australia is meant to be a first world country. An entire state lost its power. No one is immune to this. So, some thoughts. When people talk about data now, your data is in a data center somewhere. People talk about the cloud. It's not in a cloud, it's in a data center. And if the data centers are unreliable, you may not be able to access your data. Failures are common, and they're going to be caused by power, cooling, and people. And the question that keeps coming up is, are your systems truly resilient? And I don't think you can see this, so I'll have to say it. Would you pull out the plug from your data center now? Would you actually go back to your data center and say, I have total faith in my data center's reliability and resilience, so I can pull out the plug, everything will be fine. I can do it now, I don't have to tell anyone. Would you actually do it? No, nobody will do it. Because fundamentally, people are concerned that their systems won't work. But, this was a good graph. What this graph is showing you is electrical system unreliability. Everywhere around the world, the supply authorities can tell you the SAIDI and the SAIFI statistics for their networks, and they can tell you what the likelihood of failures are on their system. The one with the largest spike, some country in Asia? No, the USA. The most reliable power system in the world? Singapore. But it doesn't matter, because even Singapore has blips. So wherever you are, one day the external utility is not going to be there, and you are going to have to rely on the resilience of your data center to keep your data alive. And regulation. This is starting to appear everywhere. Now, if you want to build a data center in Singapore, you have to obey certain regulations by the government if you want financial people there. You can now actually look at a data center and see that data centers are built differently because of these regulations. In Indonesia, the government forced their banks and companies to hold data in country. This led to a whole raft of building, and resilience was a massive issue. Again, people are building data centers and certifying them to meet these regulations. So there are many reasons why people are doing it, but these are the three main ones. So what do data center operators actually want? And essentially what they want is a data center that won't fail. A data center will not be, you won't need to turn off for maintenance, it won't fail irrespective of the power, and as long as the generators are there, they'll keep running. And Uptime tier certification, when we go through that process, that is what a data center actually is. A certified data center has those characteristics, and that's why, as a shorthand now, data center operators are looking for tier facilities because they know they have the characteristics they want to give them the reliability that they need. So, what is the certification process? It starts with the tier standards, and again, these are on our website, freely downloadable, you can read them. It's a set of documents which define what our standards are. And I'm sure you'll be familiar with the tier ratings. Again, they explain these tier ratings in some data. And a question that usually people ask is, which rating do I need? And the answer is, we don't know. We're an auditor. You tell us what rating you're looking for, and we will audit to that tier level. It's a business decision as to which one you use. Typically, people use tier 3 because that's concurrently maintainable, a very reliable system that can be maintained without turning anything off. But increasingly, people are looking at tier 4 facilities, which are fault tolerant, which can survive major faults as well. But again, there's different characteristics, there's different costs, there's different feasibility, and it really is a business decision for you to decide which one you actually need. Whichever you need, we can look at the certification for that particular one. And to build a tier data center, there's a number of things you need to do. And I'll just draw out a few points. Fundamentally, we look for every tier data center, we want to know that the generators are rated to the ISO continuous rating. We also want to know there's at least 12-hour fuel storage and water, if you're using water as part of the design. But we also look to be, for the systems to be designed to fairly high temperature limits. So the ASHRAE data for the region, taking the 1 in 20 temperatures, extreme max wet bulbs. We look for that as a fundamental. I always mention these first because these things affect power, cooling, space and money. And if you're building a tier facility, you need to get these things right at the first time because these are the hard things to go back and fix later. Once you have those things in place, then depending on what tier rating you want, there's various characteristics you need. Typically, for tier 3, we look for N+1 redundancy in plant, various characteristics. For tier 4, it becomes more complicated. We look for continuous cooling. We look for compartmentalization to make sure the faults can't transfer. All of this is detailed in our standards. Also, again, we provide lots of information around this. So before you actually start a tier design process, you can go to our website and download many, many articles about tier design so you really understand what you're looking at. You then can get training as well. We do specific training on tiers, and there's many ways you can, and now there are many companies also who do get involved in tier certification. So there's lots of knowledge available on tiers. So once you've actually got to that point of saying, right, I now have a design, the process can actually start. The process is a straightforward one. It's 3 steps, where firstly we do a design certification, then we do a facility certification where we actually come and test the facility, and thirdly there's an operational sustainability certification, which is something we would do once the data center's been in operation for some time. But I'll come to that later. The way the design review works is straightforward. The standard itself is not prescriptive. It doesn't tell you exactly how to design. For instance, in Bangladesh, you have extremes of temperature, you have extremes of humidity, you have certain power conditions, but also a lot of your systems at the moment are still relatively small in global terms. And so you tend to have designs here which are smaller, based around DX systems, etc. And so that's something which is within our standard. Equally, in Singapore, we have some similar conditions because, again, extremes of temperature and humidity, but much larger data centers, 30 megawatts, etc. And those often are using full high voltage distribution, dynamic rotary UPS, chilled water, very, very different technical approach. But again, because there's a performance-based standard, they can all be accommodated within it. And so the design check itself is done by our experienced engineers. There's no specific checklist. They're looking for concurrent maintainability. And what they'll do is they will go through designs, check them again, and they'll do multiple reviews till we iron out all the issues. And so the sort of review they go through, once they've done it, they'll give you a table, and the table will explain, these are the issues we found, identify them very, very clearly, and from that you can understand what you need to do to fix it. Once you fix it, there comes a day, I promise you, where you see this, closed. All items are closed. Once you get to that point, you then will get a design certification. But that's a certification which is on paper. That says you have a design here which can work if you build this design. And what we find in practice is that that is actually a hard thing to do. To go from the process of designing to actually building, lots of things go wrong. And so to try and help you here, again, because we don't do it, but we're aware of it, because we live with it, in our journal we have lots of articles we've written based on our experience of certification and seeing how these are the sort of things we've found happening during data center constructions that affect certification. So please read this, learn from it, because later on, if there's a problem on your data center construction and it's in here, you knew already. So don't make a new mistake, please. Another article we've got is on data center commissioning. Now, commissioning means taking a data center which is not working and bringing it into operation so it is working and fully tested. There are a lot of disagreements about what commissioning actually is. So this article here, I promise you, is probably the best article you will find anywhere in the world about data center commissioning. Describes the full 5-level process all the way up to including integrated system testing. Talks about who needs to do it, what needs to do, why they need to do it. This is what we need, because our expectation when we come to a facility test is that we will be coming to witness a fully commissioned system, not come to witness the commissioning. And again, if we come on site and something can't be done because it hasn't been commissioned properly, and it's in this article, you should have known about it. So please, make a new mistake. And finally, there's also this article where we talk about the facility certification process, which explains what we do and how we go through it. So please, read those 3 articles, because they give you a lot of valuable information about what exactly goes on during the process, but also gives you a lot of ideas of the problems that can occur during the construction process. The actual facility test itself. Our intention is to come to a site which has a fully commissioned system, and we're going to witness tests. What we are going to do is a full 12-hour black building test on your building. If you say it's a 500 kilowatt data center, no problem. We want to see 500 kilowatt of test load installed, everything stabilized and working. We'll check everything, and when you're ready, are you ready? We pull out the plug. We pull out the plug, and then we watch the data center run on full load on generators for 12 hours. And while we're doing that, we also do various checks and maintenance things just to see whether, because if you're saying something can be done, like the duty chiller can be swapped out for the non-duty chiller while you're maintaining full load, no problem. We actually test all of that to make sure. It's really horrible. It's the worst thing you can do to a data center. But the important thing is we do it at a time when you're ready to do it, not at a time not of your choice. Because if you don't test your data center, One day your electrical utility will fail, most likely in the middle of a thunderstorm, when there's major disruption, and it will fail. Do you want to test it then? Or do you want to test it now? And that's why we do the facility test. But because this is so rigorous, and we're well known for doing these tests and having no sense of humour, people know we do these tests, and we're horrible to everybody. And that's why international customers see these facility tests and say, that's my due diligence. I don't need to do it. They've done it. And the way, before we get there, we actually tell you what we're going to do. So the engineers go through the design, which they understand very well, and they give you a list of tests that they want to see. So there's no lack of clarity about what's happening. These tests are given to you. What you should do, once you've tested and commissioned your data center, is actually execute all these tests yourself. So we come along, it's just a retest. And ideally, this is being done by your operators. Because I'll talk more about operations tomorrow, but the life of a data center starts when it's been handed over. Building a data center is not the purpose. It's the means to an end. And so, from the point of commissioning onwards, your operators should be able to demonstrate your systems, because they're the ones that are going to have to live with them for the next 20 years. And it's an unfortunate fact, but true, that when you build a data center, the day you finish and hand over is the day when most of your expertise, who really understands how it was built, leaves site and never comes back. And if you haven't captured that information before they've left, found a way of transferring it on, if you build a data center and then say, now I'll build an operations team, there's a massive gap. And these are the areas which are going to cause you the problems. But I'll talk more about that tomorrow. Some of the tests we'll do, and they're very, very detailed. We will actually literally, first thing, pull out the plug. Then, depending on your system, we'll actually give you very specifics. We want to see this breaker pulled out. We expect to see this outcome. These scripts go on forever. Sometimes these data centers, 200 plus tests over a 5-day period. It's really, really horrible. But once it's done, it's a lot like going to the dentist. Nobody likes dentists. Dentists don't like dentists. But after you've been, you know your teeth are fine and you don't have to see one for another 6 months. So please think kindly of us. And once you complete all that, that's when you get the facility test badges. And the facility test is different from